Hi, in this video I'm looking at calculating the surface area of this rectangular prism. Now the surface area is the sum of the areas of all of the sides of the prism or the object. So this prism, because it's a rectangular prism, is made up of several rectangles. We've got this rectangle here on the front, and that matches the same rectangle on the back. We would have this rectangle here on the side, which would also match the one on the other side. And then we have this rectangle on the top, which would match the one on the bottom. So there's three pairs of rectangles. And we can work out each of those rectangles one at a time. So if we have a look at the first rectangle, it's 9 centimeters by 4 centimeters. So we can use our area rule, length times width, and so we can do 4 times 9, and so that way we have an area for the front rectangle is 36 centimeters squared, and that would also be the same for the back rectangle. If we have a look at the second rectangle, it's got a bottom of 3 centimeters and it's 9 centimeters tall. So if we work out the area using our rectangle area rule, we're going to do 3 times 9, so it's 27 centimeters squared. And if we work out the top, now the top, if we bring the 4 up to there and bring the 3 up to there, it's a 4 by 3 rectangle for our third one. And so if we use our rectangle area rule, our third area is going to be 4 times 3, and so we have 12 centimeters squared for our final area. And then to work out the total surface area, which is sometimes SA or sometimes TSA, so SA for surface area, TSA for total surface area, we have to do, well, there's 2 of each of these rectangles. So you have to do 2 lots of area 1, and then add on 2 lots of area 2, and then add on 2 lots of area 3. So we would have 2 lots of 36, plus 2 lots of 27, plus 2 lots of 12. And so if we work that out, this rectangular prism has a surface area of 150 centimeters squared. Now that's one way of working out the surface area of a rectangular prism. Work out this 3 sides individually and then work it out. The other way is that there is a rule, because if you think about it, all of these are different rectangles. If I label the length, the width, and the height, here I've done 4 times 9, so I've done the length of the rectangle times the height of the rectangle, well, rectangular prism, because I did 4 by 9. And then for number 2, this time I did the 3, so that was the width. So I had the width multiplied by, well, the height of that is the height of the rectangle, so we multiplied by h for height. And then down here, I did 4, which was the length, and I multiplied it by the 3, which was the width of the rectangular prism. And then I did 2 each of those. And that enables us to build up a rule. You can actually get that the total surface area of a rectangular prism is, well, we've got the length times the height, so you can have length times the height, and you can add on the width times the height, so you can have the width times the height, and you can add on the length times the width. And then there were 2 each of every single one of those. And this is more commonly written as 2 times that sum of those things. So length times height plus width times height plus length times width. So you can actually use a rule and you would get the same answer. So if I do this, I can have 2 times the length, which is 4, times the height, which is 9, plus the width, which is 3, times the height, which is 9, plus the length, which is 4, times the width, which is 3. And if you look, these are the same calculations. I had 4 times 9, and 3 times 9, and 4 times 3, added together and times by 2. And so we get the same answer, 150 centimeters squared, for the total surface area of the rectangular prism. So there's 2 ways of doing the surface area of a rectangular prism. You can just use this rule, but that of course means you need to remember the rule. Or you can work out each of the rectangles, which we already know the rule for, add them up, and you're done. This is a little bit more useful if one of these sides or more than one of these sides is not counted as well, because then you got to throw the rule out the window or modify it for that particular case. So working out the rectangles separately and then adding them up as needed is sometimes more efficient, because there might be the top missing, or it might be a tube, so you might not do the top and the bottom, or it might be missing 2 sides. So it depends on what the problem is, depends on whether or not you can use this rule, or whether you just work out each of the rectangles and add them up separately.